Good morning, everyone. Okay, so we are recording this video in order to summarize what we have seen so far and has to be clear for the topics that we will cover next. Okay, so make sure that you solve the exercises that you clarified. Come to us if you have any questions. Feel free to ask any clarification that you need. I am available on Tuesdays afternoon if you need. You can ask Danny for also tutoring if you need. Okay, so these are the key ideas of the conversions that we are looking at so far. So we are doing a lot of conversions of grams to moles or mole to grams, and we always do that conversion using the molar mass of the compound that we are interested in. So just a reminder, the molar mass, for example, if you have something H2SO4, let's say that's my formula. So if you are given an amount of this compound in grams, and you need to change it into moles, you calculate the molar mass of it in order to do that conversion. And the molar mass is by looking at the atomic masses of the individual elements and add them up together to get the molar mass. The units of the molar mass are always grams per mole, and the reason is we are calculating how many grams are contained in 1 mole. So whenever I'm calculating the molar mass, I am calculating the mass in grams of 1 mole. That's my conversion factor. 1 mole equals, for example, for sulfuric acid is going to be 98 grams. So that's going to be my molar mass, and that's going to be my conversion factor whenever we have to do these kind of conversions. I'm going to explain an example to clarify this step as well. Also, another conversion that we may use is if we need to change units of volume to units of mass. To do this conversion, or the other way around, mass to volume, we use the density of a compound. Why the density? Because the density is always in these units, grams per milliliter, or grams per liter, or kilograms per liter, but it's always the relationship between mass and liter and volume. So if I have the density of a compound, is how many grams I have per milliliter of that substance. So that's why the density is useful. And finally, we are using also Avogadro's number, which is also used to calculate number of particles. In this case, number of atoms or number of molecules if you are asked to do that kind of calculations. So let's have a look at an example that you probably have solved, or maybe you are going to see in class, that includes all of these conversions together, so we can clarify a little bit how it works. So it's this one. How many atoms of each element are there in 150 milliliters of nitric acid if its density is 1.08 grams per milliliter? Okay, so if we look at the information, the only thing we are given is the volume, 150 milliliters, the formula, we can also have the formula, and we have the density. That's all we have, and we are asked to calculate atoms. Okay, if we go to the summary of the key ideas that I have just mentioned, they are also summarizing here just without words, but it's exactly the same thing. So you were given an amount in volume, and somehow you need to get to atoms. Okay, so this is going to require a few steps. It's not only one conversion factor, but a few of them. But the first one that I can do is, okay, if I have volume and I was given the density, I can convert it into mass, which is grams. Once I have mass, I can look for another conversion. For example, this one, if I have the grams of my compound, I can change it into moles using the molar mass. And I can calculate the molar mass because I was given the formula of the compound. And once I have the moles, I can turn them into atoms using Avogadro's number. Okay, so it's a few steps that we need to figure out, but we can base ourselves on the information given to at least find the first step. Okay, so what can I do with the information given? What can I convert it into from the information given? So in this case, I only have 150 milliliters. I have the density, which is 1.08 grams per milliliter. So if you notice in here, we have milliliters and we have milliliters as well. So if it is easier for you to think of this conversion as rule of threes, you can also think of that way, but then you need to turn them into conversion factors, because that's what we are looking for in the class, conversion factors. What is my conversion factor in this case? This one, density, because I can have an equality from this density. I can have, okay, let's say this is, keep pointing here. So I have 1.08 grams are equal to 1 milliliter. And that's going to be my equality or my conversion factor, or the first part of your rule of three, if you want to see it that way as well. Because you were saying, okay, if 1 milliliter has a mass of 1.08 grams, how many grams are contained in 150 milliliters? If I am proposing it as a conversion factor, I always start with the first number, which in this case is 150 milliliters. Then I use my conversion factor, which is the density, in this case 1 milliliter. So once again, why 1 milliliter? Because of the units of density, 1.08 grams over milliliter. This is the same as saying, okay, I have per milliliter, I have 1.08 grams. Okay, I am just writing it in a different way, but it's exactly the same information, just changing it or switching it as I need. Just make sure that whenever you do these conversion factors, you are keeping the number with the units that it belongs to. For example, in here, I cannot switch them to say 1.08 milliliters equal 1 gram. No, I cannot change them. I can switch, the milliliter can go up and the 108 gram can go in the denominator. Yes, it is possible. Just make sure that you keep the numbers with the units. Okay, so if I do that multiplication, 150 times 1.08 is going to be 162. 162, make sure that you show how you are canceling the units and getting the new units, which in this case is grams. Okay, now I have 162 grams. Okay, but I'm asked to calculate atoms. What else can I do? So next step that I can do is, if I have my grams as my starting point, I can turn them into moles. How I do that? If we use the formula that was given in here, the chemical formula. So my chemical formula is HNO3. So I'm going to calculate the molar mass on O3. So if you remember, we do this like by looking at the periodic table. We look for the atomic mass of each element. For hydrogen is approximately 1. If you take the decimals, that's fine. For nitrogen is approximately 14. For oxygen is around 15.99 or 16 if you want to round it up. It's up to you. It's okay if you round up the numbers, or if you don't, if you use the decimals. Both ways are fine. If we get slightly different answers, that's totally fine. Don't worry about it. So I got 63. You might get 60.2 point something or 63 point something. That's fine. As long as the process is correct, that's what we are looking for. Okay, we don't really care about the last bit of the decimals or everything else. No, it's fine, as long as the process you are proposing is correct. Okay, so be careful in here to always write with units. Always, whenever you do this process of calculating the molar mass, your units must be grams per mole, because remember that when I am doing this process, I am calculating the molar mass. It's equal to the mass of 1 mole. So by calculating this, I am saying, okay, 1 mole is equal to 63 grams. Okay, that's what I'm saying right there. So be careful. This conversion factor, I will say, it is one of the most important ones, because we will be using it over and over again. So make sure that you understand what it means and how to use it. Okay, so 1 mole equals 63 grams. Why? Because I am adding all the atoms together. This is the mass of one molecule or 1 mole of this compound. Okay, so please take it. This is your conversion factor. Okay, so that's my first step in here, because as I have grams at the beginning, now I can turn them into moles. How do I do that? I need to cancel grams, so I need to place the grams in here, and I need to write the moles in here. How many moles I have? Only 1, because I am taking it from the molar mass, which is always 1 mole. 1 mole in this case equals 63 grams. A suggestion, please, an advice, a valuable advice, whenever you are solving a quiz or an exercise, make sure that you check your equalities or your conversion factors and make sure that they are correct. For example, in here I am saying that 1 mole equals 63 grams. Is that correct? Yes, it is. Be careful, because I have seen students proposing things like 1 gram equals 63 moles, or 162 grams, and then they write in here 1 mole. Okay, so this is not correct, because 1 mole is not 162. 1 mole is what is coming from the molar mass, which is 63. So make sure that you always double check your conversion factors, your equalities, to check that they actually make sense. Same here with density. Make sure that you always double check them. Okay, so next step, so we need to solve this part. So 162 divided 63, that's going to be 162 divided 63, 2.57. So that's 2.57 moles because I am canceling grams to get moles. Okay, so for the next step, we're almost there. So now that we have moles, we can turn moles. If we go to the summary, now that we have moles, we can use moles to turn them into molecules or atoms using Avogadro's number. Okay, so that's what we are going to use at this step. How do we know if we are calculating molecules or if we are calculating atoms? So, for example, this compound is made of 3 different elements which all together form molecules. So in this compound, we are talking about molecules first. So if we need to convert this number, we will turn it first into molecules, and then we can turn it into atoms. So we have moles, we take the Avogadro's number. So always as well, be careful to check that your Avogadro's number is proposed correctly and your conversion factor makes sense. In this case, the conversion factor that is always going to be exactly the same is that 1 mole equals 6.02 times 10 to the 23. How do I know if molecules or atoms? Depends on the formula of the compound. As I say, this compound is made of 3 different elements which combined form a molecule. The only cases in which we are going to have atoms straight in this step, let me open some space in here. So the only case in which we are going to get from moles to atoms is if we have a single element in your compound. For example, metals are the most common ones, or maybe a gas, noble gas that doesn't form molecules. If you notice in here, they are single atoms, single elements. So in this one, they automatically form only atoms. We have no combination of atoms or elements in this case. So in that case, we will change from moles to add